So for little example with values, classical exercise, they say check if RSA data is okay to ensure security and possibility of ciphering and deciphering messages. So here are a few examples of values from which we will check if everything is okay. That is, n has been built as a product of two prime numbers, then e is prime with phi of n, and d is the inverse of e with respect to phi of n. So let's start with this first couple, a public key, which is published as n equal to 47 and e equal to 23. So here n is a prime number. 47 is a prime number, so it's not a product of two different prime numbers. So this public key is not okay. Second example, another couple, n e where n is equal to 143 and e is equal to 5. So first step, try to see if n is a product of two prime numbers. Actually, yes, n is equal to 11 times 13. So it's okay for n. So as it's a little number, we are able to get the two prime factors here. So from n, we can calculate phi of n, which is 10 times 12, which is equal to 120. And here, if we check the GCD of E and phi of n, actually it's equal to 5. So E and phi of n are not co-prime numbers or relatively prime numbers. So the choice of E doesn't respect the constraint that E and phi of n must be co-prime numbers. So here, this public key is not correct because n is actually a product of two prime numbers, so it's okay for n, but E doesn't suit the requirement for the public key. Okay, next example here, where we will check also the private key. So n E is equal to 143, and E has been chosen equal to 47. So here, actually, n is still a product of two prime numbers. Phi of n is 120, and the GCD of 47 and 120 is equal to 1. So E is okay. Then you're told that the private key D is equal to 29. So here E is okay. Now, is D correct with respect to the values of N and E? Actually, as D is supposed to be the inverse of E with respect to phi of N, we should have the following equality, is that E times D is equal to 1 modulo phi of N. So this is a way to check if the values of E and D are correct, one for ciphering, the other one for deciphering. Here E is 47, D is 29, so the product is 1363, and 1363 modulo 120 is equal to 43. So it's not equal to 1. So actually, N is okay, E is okay, but D is not okay. So this key set where N and E seems to be correct actually is not, because D here is not the private key. No. Last example, an example that here will be okay. So we'll keep the same values for N, choose another one for E, so 143, then E, which is equal to 17. So here you can check that N is okay, E is okay with respect to phi of N, and then you're told that D is equal to 113. Then here, to check the values of E and D, we can try the following calculation. So E times D modulo phi of N, and then you find it's equal to 1. So it's a definition of inverses. Here, N and E are okay, and from phi of N and E, the value of D is also correct. So remember, if you have such an exercise to handle, first check that N is a product of two prime numbers. Then check that E is co-prime with phi of N, and if you're given the value of D, you have to check that E times D is equal to 1 modulo phi of N. Okay, don't try to make calculations modulo N for E and D. It's E times D is equal to 1 modulo phi of N.